All right, so let's practice a little bit. So here we have a function, and ignore this part right here. We'll come back to that in a second, okay? So if we have a function like this, right, and we can see a different representation of it there with the 1 over x plus 3 to the fourth, quantity to the fourth power. So remember, if we have a situation where we have 1 over a binomial and it's raised to an even power, so here n is even, then remember what's going to happen is this will always be positive, right? If I raise something to an even power, it'll always be positive. So if I have a positive 1 divided by a positive value, then we know that no matter what, these are going to be positive, right? Okay, well, let me not do the last one because I don't know if the limit exists, but we know that these are going to be positive, right? So it doesn't matter what side we approach from, we're going to get a positive. And as this value here, we're approaching -3. So notice how there's a negative in front, by the way. That negative is just attached to 3. That doesn't mean left or right. That just means we're approaching this negative value, right? And then these tell us from the left or the right, those superscript values, right? Those values that are raised on the right side. So this is approaching -3 from the left. This is approaching -3 from the right. So as we approach from the left, we're going to have numbers that are smaller than -3, like -3.1, -3.01, -3.001. And as we add those to +3, we're going to get a negative value that's going to get closer and closer to 0, right? But on the negative side. But if we raise it to the fourth power, those numbers are going to become positive. And as we do 1 divided by those numbers that get closer and closer to 0, we're going to get larger and larger values. And so they'll approach infinity, right? Positive infinity. Okay. Same thing right here. If I put in numbers that are close to -3 on the right, that's like -2.9, -2.99, things like that. And so that's going to get us closer and closer to 0, but on the positive side. But if we raise it to the fourth power, we're still going to end up positive, right? And so it'll approach positive infinity. And since it's the same on both of these, our final limit, our two-sided limit, is going to be also positive infinity. Okay, so that's how we use this rule. And so since we had a positive even integer for n, that means our two-sided limit is going to be positive infinity, right? Because it's going to go positive infinity on both sides. All right, let's see what happens if we have an odd integer. So here's another set of examples. And so this time we're approaching +6, right? And we have x minus 6 here in the bottom. And so we know this is going to get closer and closer to 0, right? But this time we're raising to an odd exponent. Okay, so n is odd. So what's going to happen is if I approach from the left, if I put in numbers that are left of 6, like 5.9, 5.99, and everything into this, then I'm going to get numbers that are closer to 0, but they're going to be on the negative side, right? And so if I raise a negative to a fifth power, it's still going to be negative. So +1 divided by a negative is going to be negative, and those numbers are going to get super small in the they're going to be large absolute value wise, but they're going to go in the negative direction, right? So it'll approach negative infinity. Okay. Here, if I approach from the right, I'm going to get numbers that are slightly bigger than 6. And when I subtract 6, those are going to be positive, right? But they're going to get smaller and smaller, closer to 0. And so as I divide 1 divided by a number closer to 0, I'm going to approach infinity. And since this is going to be positive, because any positive raised to an odd power is going to be positive. And so that means this will result in positive infinity. All right. So when we're approaching, when this is odd, if we approach from the left, we're going to get negative infinity. If we approach from the right, we're going to get positive infinity. And what that means is, since they're different, that means that this is going to be, does not exist, right? The two-sided limit does not exist because it's going in different directions. All right. So what we just saw was these happen, right? This was what happened in the first one that we looked at. where they both went up to positive infinity on either side, and this is what it looked like on the second one that we did, where the one approached positive infinity and the other one looked like the other one approached negative infinity. Now, when this happens, when you have a function approach negative infinity on either side, we talked about this invisible boundary, right? Instead of going and crossing that boundary, what happens is the function veers and it goes up forever, right? Or it veers and it goes down forever. And so when you have a boundary like that, that's called an asymptote, okay? And it's a vertical line, so it's going to be x equals a number, and that number is going to be whatever a is, right, in those situations. And notice how it's a negative a in here, and here it's positive a, right? So it's always the opposite of whatever values inside those parentheses, okay? Here, same thing. This would be x equals a, right? So we have an invisible boundary here as well, okay? So what this says is, oops, wrong one, sorry. So if any of the following conditions hold, then we have a vertical asymptote, right? Okay, so if we have on one side, from the left or the right, we have a graph that approaches positive infinity or negative infinity, okay, then that means we have an asymptote at x equals a, right? So notice a is what we approach. So if we approach a number and the output approaches infinity or negative infinity, then we have an asymptote there, right? Or if the two-sided limit approaches positive infinity or negative infinity, that means we have an asymptote, okay? All right. So here we obviously have asymptotes, right? Here we have a two-sided limit that approaches infinity. Here we have on one side approaches negative infinity, on the other side approaches positive infinity. And so that means we have asymptotes, right? Here, in this situation, it's going to be x equals -3, okay? Right here, and notice how it's the opposite of this, right? And so, yeah, it's the opposite of whatever that value is. So here our asymptote is going to be +6, right? X equals +6. All right. Okay, so if you approach infinity from infinity or negative infinity from either side, or from both sides, I should say, then that means you're going to end up with the asymptote, and the asymptote is going to be x equals a number, whatever that number is that you're approaching, okay? And if you look at the function, it's going to be the opposite of whatever number's inside the parentheses there. All right, and don't forget to put x equals, right? If you just put 6 for an asymptote, that's not right, because an asymptote is a line, and so you have to make an equation to represent a line, okay?